All right, we're going to work a problem from start to finish on getting everything written out, from our formulas to predicting our products to identifying who's going to be solid, liquid, gas, aqueous, and then also to the point of doing your Netionic equations. All right, so what if we have iron 3 nitrate, and we are told that we are going to place it in a solution of lithium, let's go dichromate. All right, so that's dichromate. Sorry, ran out of room. Cr2O7. He's a 2 negative. All right, so the first thing that you're going to do in any of these problems is exactly how you've been taught to do everything. You've done it in order, and what I mean by that is we started off finding out the charges of things. So iron 3 is iron Roman numeral 3, okay? It means that he's got a charge of 3. Nitrate is not nitride, it's a polyatomic on the bottom of your table, and he's a -1. So for iron 3 nitrate, our formula is FeNO3, 3. All right, so why do I need 3 of those? Well, we've got the 3 different ways, remember, that we've looked at this. If iron's got 3 electrons to get rid of, and nitrate, which is NO3, can only take 1, you're going to need 3 NO3s. That's one way. The other way is least common multiple. We've talked about the closest number 3 and 1 have in common is multiples of 3. You would need 3 of the nitrates to get you 3 electrons being taken. Or the drop and switch, which, remember, is not always fabulous because it can go wrong, but the drop and switch is taking the 1 down and the 3 down. Okay, so that's the other way that we could do that. All right, so now that we have our formula, I'm going to go ahead and start from here and say, hey, this guy's aqueous. And how do I know? Because the nitrates are always going to have the ability to be aqueous. Okay, next substance then. So our next substance, we have lithium, who's in family 1, and we've got dichromate, who's a 2 negative, and that comes from the bottom of your periodic table. Li2Cr2O7. That 2 is kind of hard to tell. I'm going to try to rewrite him again. Okay, so same thing. We could go through all the ways that we got that. It is the least common multiple. It's drop and switch. It's drawing the picture. Okay, this is a double displacement reaction. How do I know? I have 2 cations and I have 2 anions. So this cation is now going to combine with this anion. So I'm going to draw an arrow. I just ran out of space here. I'm going to get Fe2Cr2O7, 3 plus Li is going to combine with NO3. He's a +1, he's a -1. I get LiNO3. This is my skeleton equation, or my skeletal equation, sorry. That means it's the equation without being balanced. We are now going to take this into being balancing and identifying what type of substances each one of these is. So picking up from here, we already said that iron 3 nitrate was going to be aqueous because nitrates are always aqueous. Lithium is going to be always aqueous because it's family number 1. We go to the other side, we know that this lithium nitrate's always going to be aqueous. That means this guy is going to be our solid. We're going to now go through and balance our equation. So we've got 1 iron, 2 irons. So I'm going to put a 2 in front of this. That gives me 6 nitrates, so I'm going to put a 6 there. That gives me 6 lithium. I need a 3. That gives me 3 chromates, 3 chromates. We're good. All right, our next thing then. Trying to figure out who our spectator ions are. So your spectator ions are the ones that are in solution on both sides. So this lithium nitrate right here, notice how it's in solution on the product side. If it's in solution on the product side, it was in solution on the reactant side. These guys are your spectator ions. So lithium and nitrate are your spectator ions. So whoever is in solution on the product side is going to be your spectator ions. From there, we've got our net ionic equation of Fe2Cr2O7 3. This guy was a solid. How did I get it? I got it from 2 iron who were in solution. And I got it from 3 of the chromates, and I kind of ran out of space, who were in solution. So if I come back up here, sorry, I got to move a few things around. I've got 2 iron that are in solution. I got 3 chromates who are in solution to form my solid. That's my net ionic equation.